to take a look at comparing exponential, linear, and quadratic all together. So you're going to make a new tab. No need to cut it. Just going to title it All Comparison. Pause the video and copy this down. All right, when it comes to the graph, make sure you copy down exactly what it looks like. Even spaces, the x-axis goes up in ones and the y-axis goes up in twos. Every day, each zombie is able to infect 3 people. New zombies have infection powers. So when you first start off on 0, how many zombies do you have? 1. That person infects 3 new people every day. So you're going to do 1 times 3 plus the one that's already there to give you a total of 4 on day 1 after you infect 3 people. Now, your new zombies have infection power, so on day 2, you're going to start off with how many zombies? 4. Those 4 zombies are going to infect 3 new people, so it's going to be 4 times 3, plus the 4 that were already there before is going to give you a total of 16. On day 3, you have 16 zombies. All of those infect 3 people, plus the 16 people that are already there gives you 64. That's a listening check. Instead of the 4 should be 16. Day 4, you have 64 zombies infecting 3 new people, plus the 64 gives you 256, and so forth and so forth. So let's see if we can see a pattern so we don't have to keep writing this down. Let me see if I add a certain number. So 4 minus second number minus first number is 3. Then if I add 3 to that, will I get the next number? No. Let me check division. 4 divided by first number is 4. If I keep multiplying by 4, will I get the next number? Yes. So I'm multiplying by 4 each time, which makes this an exponential function. So I'm just going to multiply by 4 and get the rest of my numbers. And I'm just doing 3 at a time to save on time. This is a listening check. Go ahead and circle number 6, day 6. Okay, round 2. Each day the zombie infects 3 new people, but the zombies cannot infect anyone. So it's always going to be that one person infected. So day 0, you start with 1. Day 2, you're going to have that one person infecting 3 people. So a total of 3 new infections, plus the one that's already there, the original zombie, will give me a total of 4 zombies. On day 2, now instead of you having everyone infect, which would have been 4 times 3, you're now going to have just that one zombie infected. So it's going to be 1 times 3. So all of them are going to be 1 times 3 plus whatever is already there. 1 times 3 plus whatever is already there. 1 times 3 plus whatever is already there, which is 10. Alright, so what's happening here? I can see if I do second number minus first number, the difference is 3. If I add 3 to every number, do I get the next number? I do. So I'm adding 3 to every single number. So I can go ahead and refill everything out without having to write it out. Just by adding 3. And I can do it 3 at a time to save time. This is a listening check. Color in this box with the 22. Alright, day 3. Each day, the zombie learns how to infect an additional 3 people per day. New zombies cannot infect anyone. So every day, so start off with a zombie infects 3 people, right? And then add the one that's already there, it's 4. But now he's learned how to infect an additional 3. So instead of 3 people he's infecting 3 more people, which would be 3 plus 3, which is 6. Plus the people that are just this one zombie, that's why it's always going to be 1. So it's 1 times, and then an additional 3 every time. So 3 plus 6 9 plus the original 10 is going to give you a total of 19, and we're just going to keep adding 3 every time. So 9 plus 3 is 12, plus another 3 is 15, and then you add in whatever your total of zombies is all the way down. Alright, now I'm going to check what kind of pattern this is. So I'll check division first. So if I multiply by 4 every time, do I get the next number? No. Let me check subtraction. If I add 3 every time, do I get the next number? No. So this must be a quadratic, or I hope it's a quadratic. So I'm going to check the second difference. So keep subtracting and seeing what the first difference is. That's 12, then that's 15. And I'm going to check the second difference. The second difference is adding 3 every time. This is a listening check. Color in the box that has round 3. Alright, so it's a quadratic. Now there's no shortcut on this one because I'd have to calculate the missing numbers. So I'm just going to keep doing this pattern all the way down, but just on my calculator. So after 15 would be plus 3 would be 18. Alright, plus the 31 that was already there, 64. Then 18 plus 3 would be 21, plus the original 64 would be 85. Then what was the number 18 plus another 3 would be 21, plus the 85 would be 106. Then when we're on 21 plus 3 will be 24 plus the 106 is 130. And the last one. Right? So those are my numbers. Now the question is, what function is it? Well, because we're multiplying on the first, and that's going to be exponential. Because it's the first difference on round 2, that's going to be linear. And second difference would be quadratic. Right, let's take a look at an equation. For exponential, what's the general equation? Y equals parentheses b raised to the power of x. Where a is whatever you're starting with, or where x is equal to 0. B is going to be your rate of change, and x is your time. So that's going to be y. What I start with is 0 is going to be 1. My rate of change is going to be 4, because I'm multiplying by 4 every time x, and simplifies to that. Alright, for linear, what's the general form? Y equals mx plus b, where m is your slope, your change in y over your change in x, and because my change in x is always 1, it's really my change in y in this part, and b is where it intercepts the y-axis, where x equals to 0. So, what is my slope? Change in y, which is 3, over my change in x, which is over 1. And where is x equals to 0? It's 1. Simplify that, I'm going to get 3x plus 1. What's the general form for quadratic? Y equals ax squared plus bx plus c, where a is your second difference divided by 2, and c is your y-intercept, or where x is equal to 0. So, second difference is 3 divided by 2x squared, and then my intercept is where x equals 0 is 1. Now I'm going to show you how to use the calculator to find what you're missing. So you're going to hit stat, and then you're going to enter in 5 values should be enough. Your x, and now your y, which is 4, 10, 19, 31, and 46. Then you're going to hit stat again, so watch my finger. Stat. And now you're going to hit calculate, and then what do you want it to calculate? The quadratic. So you're going to go down to quadratic, press enter, and it's going to tell you what a, b, and c is. And it's going to give you in decimals. 3 over 2 is the same as 1.5. So my b is also 1.5. So my b, the one I was missing, is 3 over 2x. So again, it's going to be, I'm going to write it down on the side for you, so copy it down. You're going to hit stat, edit. You're going to put in the table when you put edit. Then you're going to hit stat again, then calculate, and then you want it to calculate your quadratic. And the cool thing about this is you can actually use it to calculate your linear, and you can use it to calculate your exponential. So if you do that now, so I'm going to delete my y values, my x values are changing the same, and I'm putting round 1 in there. And then when I hit stat, this is going to be exponential. So I'm going to hit stat, go to calculate, then go down to where I see exponential. Listening check, color in the first box that has stat. And that's exponential. Press enter, and you see a is 1 and the change is 4. Let's do the same thing for linear. Stat, stat, enter, and then change the y values because x values stay the same. And then when I hit stat, I'm going to look for what linear. So you have to know what it is before you do it. So linear. Press enter, and you can see a is 3 and b is 1. Okay, so how many zombies will there be after 30 days for each round? So I'm going to write down the original equations, the equations I just found for each round. And then it's what will it be after 30 days? So what they're saying is x is your time, right? You're just going to put 30 where you see x in all the equations. So where you see x, just put 30. This is a listening check. Underline round 2. I just plug it in the calculator. This number is so big that it's in scientific form. What that means is you're going to write 1 times 2 times 10 to the power of 18. And this one is 91. Plug that one in. Don't forget, when you have fractions, put them in parentheses. I'm going to do like 1 by 1, like each unit by itself. So I get 1,396 zombies. So when 30, which one's going to have the most? Round 1. Which one's going to have the least? Linear. Round 2. Alright, so let's graph this, and all you have to graph is just go to the x value, then go to the y. So when x is 0 in round 1, y is 1. When x is 1, y is 4. When x is 2, y is 16. When x is 3, it's 64, it's out of the page. So now I'm just going to do a rough sketch of that. So I'm just going to join those points so it grows really, really quickly, really fast. In a different color, let's do round 2. When x is 0, it's 1. When x is 1, it's 4. When x is 2, it's 7. When x is 3, it's 10. When x is 4, it's 13. When x is 5, it's 16. When x is 6, it's 19. And you can see it's just going to be a straight line, so I'm just going to use a ruler and join those up, which I expect it to be linear is a straight line. Right, and then the last one, and you're going to do this in 3 different colors. The last one, when x is 0, it's 1. When x is 1, it's 4. When x is 2, it's 10. When x is 3, it's 19. When x is 4, it's 31. When x is 5, it's 46. That's too far. Right, then you're going to join it. So I do expect a curve. So you can see exponential grows really, really quickly. Quadratic is more of a constant curve, and linear is a straight line. Now you're going to have done that in 3 different colors, so I'm making a key. For me, my exponential is black, my linear is blue, and my quadratic is red. Now, I do need to point this out because this is a question they ask you. The closer you are to x, the slower you're growing. So the closest line is the blue one. That's the slowest growing one. The closer you are to y, the faster you are you're growing. So what's that line? The black line, which is the exponential one. And that's pretty much it. So let's practice.